What if it's hard to see the two individual rectangles or even more that are in an irregular rectangular prism? Let's take a look at this example over here. There are so many pieces labeled, but it's hard for me to see what the actual rectangles are when I take apart this irregular rectangular prism. Because we know to find the overall volume, in order to find that, I need to add together the volume of A plus the volume of B. So let's take a look at our rectangle and figure out what is A, what is B. So I see, first and foremost, when I look at this, I see a natural divide right here. I see one rectangle laying on the bottom and another one on top. I could, however, also see it like this, where there's two rectangles pushed together. Let's use this example for this problem. Now, I'm going to call the rectangle on the left A. I'm going to call the rectangle on the right B. So let's look at A first. We know that it's going to be length times width times height to find that rectangle's volume. And I think all of those are pretty clearly labeled. 3 is going to be our length. Our width is going to be 10. And our height is labeled as 6. Now let's take a look at volume B. Again, it's length times width times height. When I make B this rectangle off to the side, I see that the length of it is 7. And that makes sense because the whole length of the entire rectangle is 10. So if the length is 3 for A and 7 for B, 3 plus 7 equals 10. So I know that that makes sense and that works. I also see that the lengths match, or not the lengths, the widths match. 10 is the width for B as well. And my height is listed off to the side as 2. You guys are going to be tasked right now with finding that overall volume using the equations we have set up and then adding both volumes together. You're then going to be asked, how would I split up a different rectangular prism?